morning, students. Welcome back to our physics lesson. In my previous classes, I have discussed about rest, motion, distance, displacement, speed, velocity, non-uniform speed, non-uniform velocity. Okay? Now, when we were talking about non-uniform velocity, we talked about average velocity. Remember? Average velocity. And while defining this term, average velocity, we come across one word, we call it acceleration. That is, I said, keep it for the next class. Today, we are going to have that acceleration in our discussion. And we are going to find out how this acceleration works, how this term came in our physics. So, start. Whenever you are driving a car, the car starts with, say, velocity 40 meters per second, attains the velocity of 60 meters per second, say in 10 seconds. What has happened? The initial velocity of the car has increased in 10 seconds and reached a greater value. Car has accelerated. You might have come across this term, accelerator, in your daily life. When you are driving, of course you are not allowed to drive, but if somebody is riding a motorcycle, then there is accelerator. Somebody is driving a car, say your dad driving a car, he has accelerator in the car. In your layman's language, we call it race. So what happens when you give race or acceleration to your vehicle? Its velocity increases, isn't it? Yes. So, whenever we come across the term acceleration, we say that the velocity of or the speed of, forget the direction, or the speed of the vehicle is increasing with respect to time. If a body is initially moving with 10 meters per second and attains another speed 20 meters per second in 10 seconds, what has happened? The speed or velocity of the body has increased by 20 minus 10. That is 10 meters per second in 10 seconds. Agreed? That's fine. So, let us define acceleration. Acceleration is defined as the rate of change of velocity. Once again, just look at my presentation. Acceleration is defined as the rate of change of velocity. That is, acceleration is equal to change in velocity upon time. Good? Got it? Yes. This change can be positive, can be negative. Think, can this change be positive or negative? Well, we will talk only about the positive change. Negative, keep it for few minutes. I'll come later on. So, rate of change of velocity is acceleration. How you will write it mathematically? Suppose if a body has initial velocity u and final velocity v, then its acceleration will be v minus u whole divided by t. Not clear? Okay, back to my presentation. See that if a body has initial velocity u and it attains the final velocity under uniform acceleration a in time t, then the acceleration a will be equal to v minus u whole divided by t. Final? Good. Now, let us come back to this term acceleration. You know, when we were studying velocity, speed, we were talking about uniform speed and non-uniform speed. We were talking about uniform velocity and non-uniform velocity. Here again, we have uniform acceleration and non-uniform acceleration. Non-uniform acceleration is none of our business. Our dealing in the complete chapter will be with uniform acceleration. Okay? So whenever we will talk about acceleration, we will talk about uniform acceleration only. Now, how can we define it? Try to define. If you can, then well and good. If not, come back to the presentation. Uniform acceleration is defined as when an object travels in a straight line. Make sure it's important that straight line. When an object travels in a straight line and its velocity increases or decreases. Let's keep that word or decreases for later consideration. Just we take increases. So once again, when an object travels in a straight line and its velocity increases by equal amount in equal interval of time, the body is said to be in uniform acceleration. Good? Can you think of any example for that? When a body is having uniform acceleration? Think. Suppose you drop a stone from the second floor. It falls. And how does it fall? It falls under uniform acceleration. This uniform acceleration is called acceleration due to gravity. That all details we will study as we move further in our chapter. Well, so very common example of uniform acceleration is that a freely falling body undergoes uniform acceleration. Can you guess how much is that uniform acceleration? It is 9.8 meter per second square. Wow! Can't get anything out of it? Forget it. Roughly it is 10 meter per second square, and that is a very, very big acceleration. When we will discuss this, we will talk about so many things about this acceleration due to gravity. But make sure one thing is clear, that whenever a body falls freely, it falls with the uniform acceleration, and that uniform acceleration, we call it acceleration due to gravity. While talking about acceleration, I said the unit meter per second square, 9.8 meter per second square. Well, that is, how does it come? Why we call the unit of acceleration as meter per second square? Or why do we express acceleration in meter per second square? Can anyone work it out? Work it out, think, and try to get it why it is meter per second square. Well, if you got it, fine. If you cannot, back to my presentation, just see that. Here, acceleration, it is v minus u whole divided by t. That v minus u is basically what? Velocity. And unit of velocity is meter per second. Of course, the SI unit of velocity is meter per second, divided by SI unit of time, that is second. You work it out, it comes out meter per second per second. That is meter per second square. So, make sure it is very, very, very important to know the SI unit of acceleration. Most of the students do mistake in that. They get confused with the term meter per second square. So in the exams they write wrong unit. And you know what happens when you write wrong unit. Well, so we discussed acceleration and its unit. Now, remember the definition of acceleration when we were talking about. If the velocity increases. Now, what if the velocity decreases? Can we call same acceleration term? Of course, you can call it negative acceleration. So people, to make your work simple, they gave one more name to it. And that negative acceleration is called retardation. So, back to my presentation and see how do we define. When the velocity of the body decreases, that is, final velocity is smaller than the initial velocity, we get the term retardation. That is, when v final velocity is less than u, then we have v minus u upon t equals minus a. This negative sign shows retardation. So if a body is having a equals minus 2.5 meter per second square, what does it mean? It means that the body is slowing down. Body is retardating. So that retardation is considered when the body is slowing down. In our day-to-day life, what happens? When we apply brakes to a vehicle, what happens? Vehicle slow down. So we get the term retardation. Now, I will give you some quick mental work. And let's see how many of you can do it mentally and very fast. A body is moving with the velocity or speed, whatever you call it. For our purpose, a body is moving with initial speed of 30 meter per second and it attains the final speed of 40 meter per second in 1 second. What will be acceleration or retardation? First of all, will there be any retardation? No. Why? Because the velocity of the body has increased. So final velocity is bigger than the initial velocity. Therefore, no business of retardation. What will be then acceleration? It will be 40 minus 30 divided by, work it out and get it. Another question. A body is moving with the initial speed of 30 meter per second and attains the final speed of 10 meter per second in 20 seconds. What will be acceleration or retardation? Well, little mental mathematics. First of all, think, will there be acceleration? Yes or no? No. Why no? Because final velocity here in this case is smaller than the initial velocity. That is, the body has slowed down. It means the body is having retardation. How much is the retardation? Well, you do your multiply, divide and work it out. Generally, while dealing with this topic of motion, we come across the terms which we have studied so far in these 3 classes. That is distance, displacement, velocity, acceleration, retardation and that. And distance. Whenever we talk about all those things, there are 2 technical terms which you have to keep in your mind. 2 terms. Number 1, that is when a body starts from rest. Full term question will say A body starts from rest and gets blah 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 blah. None of our business. What does this a body starts from rest means? Think. Well, it means the initial velocity or speed of the body is 0. Correct? Once again, when a body starts from rest, technically, what is 0? U equals 0. Another term. A body starts with a velocity of blah blah blah, moves to a distance blah 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 and comes to rest. Now, comes to rest, catchword. When a body comes to rest, what will be the final velocity? When a body comes to rest, what will be the final velocity? Those who can get it? Yeah, final velocity will be again 0. So two terms. A body starts from rest, initial velocity 0. A body comes to rest, final velocity 0. Got it? So all the basic terms I have explained so far. While interacting with the students and their posts, I came across so many queries. Some queries are genuine, some are not so that genuine. Of course, thank God this time nobody wrote, sir, where we will do, what we will do and all that. But somebody said some questions are missing. Some picture is not that properly taken. Don't worry. Use your little head, try to complete the sentence. If you cannot, forget it, don't do it. But I wrote only 3 people that don't do it. And more than 20 people did that and showed it to me. So what about those people who are struggling? I told you in the beginning, not to be afraid of this stupid numericals when they come across you. Take it as a challenge and fight it back. Do it, whether do it right or wrong, but do it. What I want you to do is to drill up your head so that you can perceive or you can even imagine in higher topics when we move on how to get these numericals done. Another way, shortcut way to tell you how to do numericals. Number 1, forget that it is going to be right or wrong. Number 2, make sure you are very clear with the definitions and units and the scientific terms involved in your question. Number 3, simple mathematics is used. Maximum simple linear equation which you have been doing right from standard 7, 8. So not a big deal. They will give you 3 quantities. Out of 3 they will give you value of 2. You have to find the value of 1. Simple. They will give you initial speed, final speed, time, and then they will tell you find out acceleration. Simple. Provided you know the definition of acceleration. Similar. Next, very important thing about doing numericals is that you try to visualize these numericals